Configuring and managing virtual storage, Module 6. It's important to note you have several different storage options that give you the flexibility to set up your storage base for cost performance, and manageability requirements. Shared storage is useful for disaster recovery, HA, which is high availability, and vMotion, which is moving virtual machines between hosts. There are 6 lessons in this module. Storage concepts, fiber channel storage, iSCSI storage, VMFS data stores, NFS data stores, and vSAN data stores. We're going to discuss Lesson 1, Storage Concepts. By the end of this lesson, you should be able to meet the following objectives. Describe vSphere storage technology and the data stores. And we should know what storage technologies are available within the data stores. So a data store is a logical storage unit that can use disk space on one physical device or span several physical devices. So basically we discussed it in an earlier module, and I said a data store is basically a container that holds all the files and objects needed for your virtual machines. They're logical containers, and the good part about it is that it can hide the specifics of each storage device and provide a uniform model for storing those virtual machine files. So what are the types of data stores? You have virtual machine file storage, NFS data store, virtual SAN, and you have a vSphere virtual volume. Now, a virtual machine is stored as a set of files in its own directory or a group of objects within the data store as you see here. Data stores can also be used to store those ISO images, virtual machine templates, or anything associated with those VMs. So in this slide, this is host 1, host 2, ESXi1, ESXi2. And you'll notice that we have VM1 up here, VM2, VM3, VM4. Well, the concept here is those 2 hosts and those 4 virtual machines share that entire data store. So in this slide, it's important to know that your ESXi host, which are up here, need to be configured so they have access across all data stores. So when we say to have access across all data stores, it needs to be shared. Now, within that shared data store, we have our different data store types. We have our virtual machine file storage, which comes down through the directly attached storage with its own LUN. That direct attached storage is the internal and external storage of the disk or arrays attached to the host that have a direct connection instead of a network connection. So we have direct connection right here, and that's why it's called direct attached storage. All right. In our virtual machine file storage, we'll have the fiber channel. And what that is, it's a high-speed transport protocol used for SANs. All right, what about FCOE, fiber channel over Ethernet? Those FCOE frames, fiber channel over Ethernet frames, are converged with other types of traffic on Ethernet, on the Ethernet network. And what this does, it does it by carrying both Ethernet and the fiber channel across the same Ethernet link. that uses the physical infrastructure because the increased capacity it can do. Then we have our iSCSI storage. iSCSI is basically a SCSI transport protocol that enables access to your storage devices and cabling over your standard TCP/IP networks. Okay, so we have our NFS storage. Our NFS storage basically contains it over Ethernet to our file system. What's in those file systems? We have our vSAN, which is a separate from a virtual machine file storage. It's directly attached to our vSAN cluster. Our NAS storage is basically storage that is shared over a TCP network, IP network, at the file system level. Then we have our vSphere virtual volumes. It's connected over fiber channel over Ethernet. As you see right here, it has its own storage container. iSCSI, NAS, and your fiber channel Ethernet can run over 1 gigabit Ethernet or 10 gig. Now the 10 gig provides increased storage performance levels and sufficient bandwidth that allows multiple types of your higher bandwidth protocol travel, or basically traffic, to coexist on that same network, to make it run faster, to make it more accessible. So as you see, you have your virtual disk here. We have our data store types here. How are they transported? And what are they backed by? So they're transported directly attached, fiber channel over Ethernet, iSCSI. Your NFS is over Ethernet. Your vSAN is over your directly attached storage. And your virtual volume is fiber channel over Ethernet. Go to our file system, vSAN cluster, and a storage container. Now you notice down here we have LUN 1, 2, 3, and 4. Storage protocol overview. In this slide you'll notice the storage protocol, which we discussed in the previous slide a little bit, or just kind of highlighted. Looked at the concept. Fiber channel. Well, you'll notice you got boot from SAN support, vMotion support, high availability, distributed resource scheduler, DRS, and raw device mapping. There's only 3 protocols that support all 5 of these. Fiber channel over Ethernet, and iSCSI. NFS only supports vMotion, high availability, vSphere DRS, and does not support raw device mapping. DAS does not have boot from SAN support. Has vMotion, but it does not have high availability, your distributed resource scheduler, but it can do raw device mapping support. Your virtual volumes, you can't boot from the SAN support. No boot from SAN, so there's no support available, but you can vMotion. There is support for your high availability. There is support for your DRS, distributed resource scheduling, but there is no support for your raw device mapping. And last but not least is your vSAN. No boot from SAN support. You can vMotion, which you can do across all of these. You got high availability support, distributed resource scheduler, but no raw device mapping support. Now, one thing in comparison here, I want you to understand. Storage LUNs must be pooled and shared, basically, so that all ESXi hosts can access them. So, what is the shared storing features with vSphere? What are they? Well, they're vMotion, which is here. their HA, and their DRS. ESXi supports several different methods, as you see, of booting from SAN to avoid handling maintenance of additional local storage. So if you got local storage, it avoids that maintenance of that additional local storage as if you had to make those hardware configurations. What if you had a blade go bad? ESXi hosts allow booting from your software iSCSI here, which is great. And what that is a supported independent hardware SCSI adapter that is supported dependent from that hardware iSCSI. The network adapter must be support only, or the network adapter must support only the iSCSI boot firmware, which is a method of communicating those parameters about the iSCSI boot device to that operating system. So as you see in this slide, these protocols here, know what they give you. Know if they give you vMotion. Know if they give you HA, high availability. Know if they give you distributed resource schedule. Virtual Machine File System 6. Right. VMFS 6 allows concurrent access to shared storage. It can be dynamically expanded. It uses 1 meg to 512 meg block sizes, which are good for storing large virtual disk files. And it uses a sub-block addressing that is good for storing small files, such as 8 kilobytes, and provides on-disk locking. So, with that being said, what is VMFS 6? Well, VMFS is a clustered file system that allows multiple ESXi hosts, as you see in this slide, host 1, host 2, to read and write to the same storage device. Okay? Now, that clustered file system enables a unique virtualization service that includes migration of running virtual machines, vMotion without downtime. It can do automatic restart of a failed virtual machine that is on a separate ESXi host, and the clustering of virtual machines across various physical servers. It enables IT organizations, or it can enable your IT organization to simplify your virtual machine provisioning by storing the entire virtual machine state at one central location. So you see right here we have VM1, VM2, VM3, and VM4. This is 1, 2, 3, 4. So we have VM1's files on host 1, VM2's files on host 2, or host 1, VM3 and VM4 on host 2. But as you'll notice, each VM has its own set of files within this VMFS data store, which is shared. Okay? The size of the data store, which is here, it can be increased dynamically while virtual machines are basically running, or living in it, residing in it, while they're powered on and running. And the VMFS data store, it efficiently stores both large and small files that belong to the virtual machine. So basically what it's saying right there, it doesn't matter how big or how small that VM1's files are right here. It's going to store them in this data store as long as you got the amount of room needed. It provides block level distributed locking to ensure that the same virtual machine is not powered on by multiple servers at the same time. So if that's the case, when an ESXi host fails, the on-disk lock for each virtual machine will be released so that virtual machine can be restarted on another ESXi host. So what if this host fails and we want it to start on this host? Well, that's where You got your block level distributed locking. VMFS has 3 kinds of SCSI-based storage devices. Direct detached storage, fiber channel, and iSCSI. Remember those: direct detached, fiber channel, and iSCSI. It's also important to know that a virtual disk stored on a VMFS data store always appears to the virtual machine as a mounted SCSI device. The virtual disk hides the physical storage layer from the virtual machine's operating system. So why does it do it? We'll discuss that a little later on in this class. NFS. NFS is storage that is shared over a network at the file system level. And it supports version 3 and 4.1 over TCP IP network. So NFS is basically, when you talk about shared over a network at the file system level, it's a file sharing protocol that ESXi hosts use to communicate with the NAS device. That NAS device is your storage device that connects to the network that provides file access services to these ESXi hosts. So this is your NAS device that hosts your files and folders for each virtual machine here. Now, one thing I want to point out, because NFS 3 and NFS 4.1 clients do not use the same locking protocol, you cannot use different NFS versions to mount the same data store on multiple hosts. So we have multiple hosts on the same data store right here. Just know that you can't use the same locking protocol. Accessing the same virtual disk from that two incompatible clients, what will happen is it'll cause data corruption within your virtual machines. So virtual machine 1, 2, 3, and 4, these virtual machine files here within that data store, within that cluster, it could cause them to become corrupt. What happens if that file folder system becomes corrupt with that virtual machine? That virtual machine is going to say, whoops, it has just failed. vSAN. So what is vSAN? vSAN is a hyper-converged software-defined storage, basically virtual environment. You get a vSAN by clustering host-attached storage disk, or HDDs, or you can use solid-state drives. And what it does, it creates an aggregated data store shared by virtual machines. All right. So when a vSAN is enabled on a cluster, you got a single data store that is created. Now, the data store then uses the storage components of each host within that cluster. All right? So this vSAN data store, because it's shared, it's going to use the SSD out of this host, SSD drives out of this host, 2, and out of host 3, it's going to combine them all in to where it is shared in a single cluster. Now the storage is mounted by using Object Store File System, OSFS. OSFS. Object Store File System. What it does is vSAN stores and manages that data on the vSAN data store as basically a flexible data container called an object. Now the object is a logical volume, not a physical, it's a logical volume that has its data and everything in the metadata distributed and accessed across the entire cluster, which means it's in the ESXi storage stack all the way across. Now when we get to talking about a single vSAN data store, although a single vSAN data store is created for the entire vSAN cluster, that data store can have multiple storage policies that are associated with it. And those policies can then be configured with different storage capabilities. It can also be configured as a hybrid. You can do all flash storage. You can use SSDs to create distributed shared data store that basically abstracts the storage hardware to provide a software-defined storage tier for virtual machines. Or you could use that all-flash architecture and you could tier those SSDs for more cost-effective implementation for basically have a huge write-intensive enterprise-grade SSD to cause it where it will just write faster. So the whole object here is to kind of get an overview of vSAN, what it does, and to know that it is enabled on a cluster, and once you enable it on that cluster, then that single vSAN data store is created here, which you see across. We have our entire cluster coming up here that hosts these VMs 1, 2, 3, 4, 5, 6, 7. There's vSAN. There's vSphere, which is our host and everything within it, going down to our vSAN data store. Virtual volumes. Virtual volumes, or basically takes vSAN or SAN and a NAS and virtualizes it by abstracting the physical hard resources into logical pools at a larger capacity. The vSphere Virtual Volume Storage is designed to address the requirements of your next generation storage within the software-defined data center. What are the benefits? You have lower storage cost. You have reduced storage management overhead. You can scale it a lot easier, greater scalability. And you have better response to data access and analytical access requirements for the whole virtual volume to run. So the good overview right here, which is excellent in my opinion, it's a native representation of VMDKs on a SAN NAS. There's no LUNs or volume management. And it works with all existing SAN NAS systems. Now you're at the data operation for the VMDK level. Your snapshots, any replications, or any other operations at the virtual machine level, external storage. It automates the control of each per VM service level. You have your vSphere APIs, which include your storage awareness, any protocol endpoint that provides standard protocol access to your storage. So what protocol do you want to access that storage? And the storage containers that can span an entire array. Now, with your virtual volumes, as you see here, we have encryption, dedupe or deduplication, memory caching, snapshots, replication, which we discussed all over here. And the good part about it, here's our virtual volumes, or basically our physical equipment. Well, this is our physical equipment here, and I apologize. Your physical equipment here, going up to your host, which then span into that one vSphere virtual volume, that then we get to our virtual machines. So it's shared. Raw device mapping is a file stored in a VMS volume that acts as a proxy for your raw physical device. Although it's not a data store, the raw device mapping also allows virtual machine direct access to the physical LUN. The mapping file, -rdm.vmdk, What that does is that points to a VM, to a LUN that has to be stored on that VMFS data store. Now let's look at a virtual disk. The virtual disk got the VM with its storage going down. It's the VMDK-flat or -flat.vmdk. This is our VMFS, virtual machine file storage, or NFS. And as you see right here, that's all basically a one-way street. Well, on raw device mapping, what happens is instead of storing the virtual machine data on the virtual machine disk file on that VMFS data store, which is here, you can store the guest operating system data directly on a raw LUN. So we have our virtual machine. It's coming down, and it's got our -rdm.vdk. Well, guess what? It's over here stored on a separate raw LUN, which is NTFS. And with that being said, being it can get on that raw LUN, RDM is recommended when a virtual machine needs to interact with the real disk on the SAN. So basically that condition exists when you make the disk array snapshot, where you have a large amount of data that you don't want to move onto a virtual disk, but it is part of a physical to virtual conversion, P to V conversion. So what should you consider with physical storage? You should discuss vSphere storage needs, and which should include, what are your LUN sizes? What's your bandwidth? Input-output requests per second that a LUN is capable of. Disk caching, zoning, masking, identical LUN presentation to each ESXi host, active-passive arrays, and do you want to export the properties for the NFS data stores? You should now be able to meet the following objectives. You should be able to describe the vSphere storage technology and each data store. What is vSphere storage? How does storage integrate with vSphere?